Here we have a SAT math question. Okay, let's go to the information. The expression 6 times x to the fourth power positive 17 times x square positive 7 can be written as 3x square positive a times 2x square positive b, where a and b are positive integers, or as 3x square positive c and 2x square positive d, where c and d are positive non-integers. So what is the value of a positive c? Okay, using the given information, we have to find the values of the constants a and c, and then we have to add them. Okay, first let me take the given expression as it is. It is 6 times x to the fourth power positive 17 times x square positive 17. Okay, so first what I'm going to do is I'm going to write this x to the fourth power as x square, the whole square. So because when I have the degree of this expression as 4, it's a bit difficult to factor them. So like if I write like this, I'll be able to convert this expression as a quadratic expression. Then I can factor it easily, so that I can write the factors first in this form and then in this form. Then I can get the values of a and c. Okay, so first I have written x to the fourth power as x square whole square, because the simplification is equal to x to the fourth power, because 2 times 2 is 4. Positive 17 x square positive 7. Okay, now let me assign a new variable for this x square, so that I can plug in the new variable over here and here. Then the expression will become a quadratic expression. That is, let y equals to x square. So wherever I find x square, so I can plug in y for it. So then I'm getting 6 times for this x square. If I plug in y, then I'm getting y, and we have square over here, the y square positive 17y positive 7. Okay, now let's factor this quadratic expression over here in y. Let me do it. So we have 6y square positive 17y positive 7. Okay, to factor this quadratic expression, what I have to do is I have to multiply the constant of 7 by the coefficient of y square. So when I do so, I'm getting positive 42. So now I have to get two factors for positive 42. So that the product of the two factors equals to positive 42. When I add them, it has to be equal to the coefficient of y, which is positive 7. So then I'm getting positive 14 and positive 3, because when I multiply positive 14 and positive 3, I'm getting positive 42. When I add them, I'm getting positive 7, which is a coefficient of y. Okay, now I divide both the factors by the coefficient of y square, that is 6. So when I do so, this it can be simplified further. So because both of them, both numerator and denominator over here are having the common divisor, greatest common divisor 2. So when 2 goes into 14 7 times, and 2 goes into 6 3 times, and 3 goes into 3 1 times, and 3 goes into 6 twice, and the resulting factors are 7, positive 7 over 3 and positive 1 over 2. So now to make the factoring process of this expression easier, I'm taking y over here and y over here. Now I move this denominator 3 as a coefficient of y, then I'm getting the first factor, that is 3y positive 7. Now I move this denominator 2 as a coefficient of y, then I'm getting the second factor, 2y positive 1. Okay, now in these two factors, I'm going to replace this y by the original stuff, that is x square. So when I do so, I'm getting 3x square positive 7 and 2x square positive 1. Okay, now I wrote the given expression as 3x square positive a times 3x square positive b, such that a and b are positive integers, because at the place of a and place of b, we have positive integers 7 and 1. So comparing this and this, I'm getting a equals to 7 and b equals to 1. Okay, now let's factor the same expression again, I mean this quadratic expression again, so that getting two factors in this form where c and d are non-positive integers. Okay, now let me do it. So 6y square positive 17 y positive 7 equals to, now the same thing again. So I have to multiply the constant of positive 7 by the coefficient of y square. When I do so, I'm getting positive 42. So I'm getting two factors as I've done over here, that is positive 14 and positive 3. So when I multiply them, I'm getting positive 42. When I add them, I'm getting a positive 17. Okay, now I have to divide both the factors by the coefficient of y square 6. So let me do it. This time I'm not going to simplify these two stuff as I've done over here. So what I'm going to do is I'm going to write this 6 in denominator over here as 2 times 3, and in the second one, so 3 over this 6 can be written as 3 times 2. Okay, now I'm taking y over here and y over here. So now what I'm going to do is I'm going to move the part of the denominator 2 as a coefficient of y. So here what I did is I just moved this complete denominator 3 as a coefficient of y, then I got the factor 3y positive 7, and the same thing I've done for this one, and then I got 2y positive 1. But this time I'm not going to move this complete denominator as a coefficient of y, I'm just going to move only the part of the denominator, that is 2 as a coefficient of y. So when I do so, I'm getting the first factor, that is 2y positive 14 over 3. And here some students may have a question. So why do we have to move this 2 alone as a coefficient of y? So why don't we move this 3 as a coefficient of y? So just look at it. If in case I move this 3 as a coefficient of y, then what factor will I get? I'll be getting 3y positive 14 over 2. But when I simplify this 14 over 2, I'll be getting 7, which is an integer. But here I'm trying to write the given expression in the form of 3x squared positive c times 2x squared positive d, where c and d are positive non-integers. So if I move this 3 as a coefficient of y, so then I'm getting a positive integer over here. The value I'm getting over here has to be a non-integer, positive non-integer. So that's why I'm moving this 2 as a coefficient of y. Then I'm getting the factor 2y positive 14 over 3. So the value I'm getting over here is a non-integer 14 over 3. And now in this case, so I'm just moving the part of the denominator, that is 3 as a coefficient of y. Then I'm getting 3y positive 3 over 2. The same question. So if I move this 2 as a coefficient of y, then I'll be getting 2y positive 3 over 3. So 3 over 3 is just one, like it's a integer. So that's why I just moved this 3 as a coefficient of y. Okay, anyways, I got the two factors, 2y positive 14 over 3 times 3y positive 3 over 2. Now, so I write this one as a first factor. So because we have 3x squared at first, so then I'm getting 3y positive 3 over 2 times 2y positive 14 over 3. Okay, now let's replace this y by the original stuff, that is x square over here. Then I'm getting 3x square positive 3 over 2 times 2x square positive 14 over 3. Okay, now we got the factor form of the given expression in this form, 3x square positive c times 2x square positive d. So where c and d are positive non-integers. So here c and d are positive non-integers. So comparing the factor form over here and here, at the place of c we have 3 over 2, at the place of d we have 14 over 3. That is c equals to 3 over 2 and d equals to 14 over 3. Already I got the value of a, that is a equals to 7. Now I got the value of c, that is c equals to 3 over 2. So according to the question, we have to find the value of a positive c. Okay, now let's find the value of a positive c. Okay, for this a we can plug in 7. For c we can plug in 3 over 2. Okay, now I have to add the integer 7 and the fraction 3 over 2. So for that, what I have to do is I have to multiply this integer part by the denominator of the fraction. Once I'm done with this multiplication, I can take these two as a common denominator. So when I multiply this integer 7 by the denominator of the fraction 2, I'm getting 14. That is 14 positive 3 over 2. So which is equal to 17 over 2, or if it is simplified, we'll be getting 8.5. So therefore, the value of a positive c is 17 over 2 or 8.5.